So, sociologists have been interested in the relationship between individuals and society, obviously since the founding of sociology in the beginning of the 20th century. And it was a concern of Marx and Durkheim and Weber and all these founding fathers. But it remained and indeed remains a big puzzle, just how what we call a macro level and a micro level interrelate. What complexity theory has done in the social sciences is begin to suggest ways of thinking about that relationship, new ways of thinking about it. And when it comes to computational modeling, which is what I'm really interested in, then again, you can do computer models that illustrate the relationship between the macro and the micro. So, for example, you can have institutions emerging from the interactions of individuals, and you can have institutions affecting the way in which individuals act. So upwards and downwards. And of course those sorts of ideas are not completely novel to sociologists, but having computer models makes it possible to formalize them and therefore to think about them in a more precise way than just say, oh well, there's emergence. We can say exactly what emergence under what conditions and what we actually mean by emergence.
That's great.
Well, actually, to be honest, I try and avoid the term. Partly because people are always a bit puzzled by what complexity is. So if you look at what I write or indeed what I say, I very rarely use the word. I'm happy to talk about modeling, about agent-based modeling, about emergence and things of that kind, but I tend to avoid actually talking about complexity because people just think I'm trying to be complicated. I am very privileged to be a Fellow of the Royal Academy of Engineering. I think I'm probably the only professional social scientist to be a Fellow of the Royal Academy of Engineering. So it's a great niche to be in, but to be really honest about it, I only did a first degree in engineering because of what I really wanted to do was computing science. And it was such a long time ago, you won't believe this, there was no undergraduate degrees at that time in computing. So I couldn't do computing, so I did engineering as a second best. And I did a general engineering degree, and in the final year you could specialise, and because I wasn't really an aeronautics or a soil mechanics kind of guy, I actually specialised in what they call management studies. And one part of that was the sociology of organisations, and I thought that was really fascinating. And so then I went on to do a PhD actually in the sociology of scientific knowledge, because they wanted me to do a PhD on the sociology of engineering, but then we couldn't think of what that was. So I did a PhD on trying to understand how science works. And ever since then, I've kind of straddled the gap between social science, and engineering in various different kinds of ways. And what I do now is a classic example of that. It's using techniques originally derived from artificial intelligence to try and better understand how society works. From where I stand, the really most exciting thing to do is to develop models that will be interesting to policymakers. Now, government policy at the moment, if you want to, or if you're a politician and you want to propose, let's say, a universal credit or a new tax or benefit, what do you do? The only thing that you can actually do is to try it out, actually to change the regulations, and very often the result is a disaster. I mean, imagine, for example, building a bridge or putting up a skyscraper without first of all having done the wind tunnel tests to see whether the skyscraper will blow down or the bridge will fall over and things of that kind. But that's what government policy people, policymakers are doing. They are trying out things without ever having the opportunity to do a pilot or an experiment. And there were, as it were, quite good reasons why they can't do that, because of the ethics of it, as well as the practicalities. You can't start taxing one group of people and not taxing another group of people just to see what would happen. But you might be able to build a computational model, an agent-based model, which is sufficiently close to how society or how people will react, that you can do this kind of what-if experiments. And although we're very early stages as yet, it seems to me that if we're looking for 10, 15, 20 years' time, we will be able to build models that are as useful as the kind of computational models that engineers use for trying out to see whether particular policies are likely to work or not. That's a very interesting question, and I'm not sure that I actually have a definitive answer. I think that actually there will be a blurring of the line between people who are scientists or social scientists and people who are recommending policies, not making policies, because that's ultimately the job of Parliament. But if you go and sort of open up DEFRA or DEC, the Department of Environment, Food and Rural Affairs, and Department of Energy and Climate Change, DEFRA and DEC, for instance, what you'll actually find there is a lot of people who best called policy analysts. And they're doing very much a lot of social science to help make policy. And it's those people who I think are going to have to do the bridging work between the pure science or the pure social science and the politicians. It's still, of course, going to be the case, and don't get me wrong, that you can't expect models of any kind, let alone, you can't expect social scientists to determine what the way of doing something is, or the policy should be. Policy, as the name implies, is a matter of political decision making. But if you're going to make a political decision, then one of the ingredients that you need is some good evidence. It's not the only thing, but it's an important element. The first thing is that you need to think about processes of validation or quality assessment right at the beginning. As an editor of a journal, which publishes a lot of social simulation research, I think probably of the papers that don't get published, the reason for, in most cases, is that the authors have said, "Here is my wonderful model." Full stop. What they should say is, "Here is my wonderful model, and here is how I've shown that it's a good model." So that's the first thing. Don't forget that in the excitement of writing models, don't forget it's actually a model about something. The second thing is that use technology to help you validate. So there are now computational frameworks which will exercise your model, which will help you do sensitivity analyses, will run the model 1,000 times while you're asleep on different parameter values, will help you use a proper experimental design about what values you should try in your model. But this technology exists, but it's still not sufficiently well used, especially by people doing social simulation. It's probably much more familiar to people who are doing ecological or biological or physical simulations. Thirdly, thirdly, coming back to what I was talking about in my keynote, is think about the users and what they want from the model. And I don't just mean sort of policymakers or people like that. I mean, amongst the users will be the people who are following you, your colleagues. Think about them right early on about what it is that they will want from your model, what conclusions they will draw from your model, and how they will think, the criteria that they will use for assessing whether it's a good model or not. That's 3.